Hello everyone, this is the second part of lecture number 2 of unit second. In the first part of lecture number 2 of unit second, we have discussed the solution of homogeneous linear differential equation of order n with constant coefficient when the auxiliary root has all distinct root. Okay, in this lecture we will try to find the solution of the homogeneous linear differential equation with constant coefficient. Okay, when the sum root of auxiliary equation, actually in the previous lecture we have discussed auxiliary equation has n roots. If we have a differential equation of n order, then auxiliary equation will be of n order. Okay, so auxiliary equation has n root actually and in which we suppose that some root are repeated. So how do we write the solution of the given differential equation, we will discuss here. So suppose this is case number 2. In the auxiliary equation, m is equal to m1 is repeated k times. Actually there are total n roots, so remaining roots are, here we have used k roots, okay, because m1 repeated k times, so remaining are n minus k, and the remaining n minus k roots, which are actually, suppose k, m k plus 1, m k plus 2, m k plus 3 and so on, m n minus k, because here we have n minus k root starting from m k plus 1. Okay, actually in the auxiliary equation we have n roots. Okay, and these roots, suppose that m1, m2 and so on, mk, mk plus 1, mk plus 2 and so on, mn. These are n roots of auxiliary equation, in which these k roots, suppose that these are equal, m1 is equal to m2 is equal to m3 and so on, mk, and these are n minus k roots are distinct. Here total roots are n and k are repeated, remaining are n minus k distinct root. Clear? So in this case, if m is equal to m1 is repeated k times, okay, and other are distinct, then solution of given differential equation is given by y is equal to, we start from c1, c2 x, c3 x square, and we take up to x to the power. Here we have a repetition k times, so we take x up to x to the power k minus 1. Okay, and which root repeated k times? This is m1, so we write here like that m1x, and other roots are distinct, so we use the case 1 for the root, all remaining distinct root. So here we use arbitrary constant k. We start from here, k plus 1 e to the power mk plus 1 x plus ck plus 2 e to the power mk plus 2 x. Actually these are in suffix, k plus 2 plus and so on cn e to the power mn x. Okay, this is the required solution of the homogeneous linear differential equation of order n with constant coefficient when auxiliary root has some repeated root and some distinct root. Okay, now we solve some example based on this case. There are some questions based on this case. First question is solve to the differential equation which is dqy over dxq minus 3 dy over dx plus 2y is equal to 0. So first of all we write to the given differential equation in operator form. Given differential equation is, this is actually homogeneous linear differential equation with constant coefficient. Okay, so we try to find the auxiliary equation. First of all we write in operator form. Actually here d is dy over dx is operator, differential operator, so we say that this form is operator form, 3d plus 2 and we take y as a, here this is the operator which operate on y. Okay, therefore auxiliary equation mq, just replace m in place of d and leave to the y. 3m plus 2 is equal to 0. Now actually we try to find the root of this cubic equation. So please do more practice to solve cubic equations or fourth order equations. Okay, so here we try to find one root actually. So we start from 1, we take, if we m is equal to 1, so we have 1 minus 3 plus 2, 1 plus 2 3 and minus 3 cancel out, so it's mean that 1 is root of this equation. So we write m minus 1, m minus 1, m minus 1, because 1 is root of this equation, and here is m cube, we multiply m square, this become m cube minus m square, but there is no m square, so we write here to second factor by m, here we have minus m square, here we have plus m square, cancel out. Okay, and after multiplying m minus m, what here is, we have minus 3m, so we multiply here 2, so this equation is balanced. We take here m is, m minus 1 is common, remaining factor is m square, m minus 2 is equal to 0, m minus 1 and the factor of this equation is m minus 1 m plus 2 is equal to 0. Yeah. So here we have root of auxiliary equation 1 1 minus 2. Here 1 1 1 is repeated 2 times. Okay, so we use case second. Case second, therefore solution of given differential equation is y is equal to, here we have m is equal to 1 1 minus 2. So repetition of 1 is 2 times. So we write C1, C2, we take power of x up to less than 1 repetition of multiplicity of the repeated root. Okay, here 1 is repeat 2 times, so we take here the power of x 1. Okay, which root is repeated? 1, and other root is minus 2, so we can write c3 e to the power minus 2. Here always keep in your mind the solution has arbitrary constant, number of arbitrary constant is equal to number of the roots. Here 1 2 minus 2 3 roots, so the solution has 3 arbitrary constant. Here c1 c2 c3 are arbitrary constant. So this is the required solution. There are some questions. Next question is solve to the differential equation, and differential equation is solve 16d square y over dx square plus 24 dy over dx plus 9y is equal to 0. Solution, we can write the auxiliary equation from this equation direct. Just replace m in the derivative. In place of derivative we have auxiliary equation 16m square 24m plus 9 and leave to the independent variable y. So, and this equation can be written as, this is the whole square of 4m plus 3 whole square is equal to 0. Here m is minus 3 by 4 comma minus 3 by 4. Actually here the multiplicity of minus 3 by 4 is 2. Therefore solution y is equal to c1 c2x. Here multiplicity is 2, so we take here power of x is 1. Suppose here the multiplicity of this root is 3, so we write like that c1 plus c2 x plus c3 x cube x square. Okay, but here multiplicity is 2, so we take the power of x up to x to the power 1, and which root is repeated? Minus 3 by 4 x. This is the required solution. Next question. Question is solve to the differential equation, and differential equation is dqy over dxq minus d square y over dx square minus dy over dx plus y is equal to 0. Clear? So first of all we find auxiliary equation, and auxiliary equation mq m square minus m plus 1 is equal to 0. Here m square is common, remaining factor is m minus 1 1, m minus 1 is equal to 0, or m square minus 1 m minus 1 is equal to 0, or this is m minus 1, or here already m minus 1, this will become m minus 1 whole square, m plus 1 is equal to 0. So the roots are minus 1 1 1. You can start from minus 1 or you can start from 1. Okay, so there is no problem. Therefore solution y is equal to e to the power minus x c1, and remaining roots are repeated. Okay, and repeated 2 times. So we write this c2, here we use c1, now we start from c2 plus c3 x e to the power x, and here 1 is repeated root, so this will be the required solution. Okay, so this is the solution of the differential equations when the auxiliary root has some repeated root. And now next case is when the auxiliary equation has complex root, okay, and repeated root and distinct root. Okay, so first of all we suppose that case second,